Hi everyone, this is Mrs. Snook with section 3.2. This is properties of parallel lines. And our objective is to prove and use theorems about angles that are formed when we have two parallel lines and they're cut by a transversal. So let's go ahead and take a look at our first example. So we have two parallel lines, line A and line B, and they're cut by a transversal. That means a transversal is going through them. Transversal is T, and we're given that A and B are parallel to them. Make sure that you mark the diagram. It's already marked. Those arrows mean parallel. And we're asked to prove that angle 1 and angle 8 are supplementary. So reminder, supplementary would mean that angle 1 plus angle 8 equals 180. So my plan is going to be to start with angle 1. I know angle 1 corresponds with angle 5, so they're congruent. And then angle 5 and angle 8 are a linear pair. So I think I'm going to do that. I'm going to go 1 to 5, and then angle 5 plus angle 8 is 180 because of linear pair. And then all I got to do is substitute in. So first thing you do, every time, all the time, is write your given. So A is parallel to B, given. The next thing that I said, and I marked it on my diagram, I marked angle 1 congruent to angle 5. And I did that because they were corresponding angles. Remember, if you mark it, write it. The next thing I mentioned was angle 5 and angle 8 are linear pairs. So angle 5 plus angle 8 equals 180. And that's the linear pair postulate. Now I can substitute 1 in for 5. So angle 1 plus angle 8 equals 180. And that's just substitution. And now check it out. We have the definition of supplementary angles. If I add them together and they equal 180, they're supplementary. So angle 1 and angle 8 are supplementary. And this is by the definition of supplementary. And you are welcome to just write sup if you want. All right, the next one. We're going to look through this figure. Again, we have two parallel lines. We have a transversal. This time the lines are a diagonal and the transversal is horizontally. And it says measure of angle 3 is 55 degrees. So I'm just going to mark that. That's 55 degrees. And then it says which angles are supplementary to angle 3. And how do you know? Well, the first thing I notice is angle 4 and angle 3 make a linear pair. So angle 4, linear pair. Same thing for angle 2. That's also a linear pair with 3. Okay. Now who else is supplementary? Well, angle 3 and angle 8 are same side interiors. So angle 3, same side interiors. Sorry, that should be angle 8. Now look who is congruent with angle 8, angle 6. And that's because they're congruent supplements. So angle 6 is supplementary. Let's see if we got them all. 2. Yep, that's all 4 of them. Now we're going to find the measures of angle 1 and angle 2, and we're going to state the theorem or the postulate that justifies your answers. So we're going to put down our answer, and we're going to say why. We're going to put down the reason. So angle 1, and notice that's a corresponding angle with 125, so I went ahead and marked them congruent. So angle 1 equals 125, and the reason for that is it's corresponding. Angle 2, that's going to be 180 minus 125. I get 55 degrees. There's two reasons you could use for this. You could say it's a linear pair with 125. It's a linear pair. Or you could say it's a same side interior. I would take either one. Example 4, we're going to do another 2-column proof. We're told that line A is parallel to line B and line X parallel to line Y. So let's make sure we mark them on our diagram. A parallel to B and X parallel to Y. Write your given always. A is parallel to B and X is parallel to Y. And that's given. Now we're asked to show that 4 is supplementary to 15. So I'm going to go ahead and highlight those so I can see them. Angle 4, supplementary to angle 15. Now notice they're not on the same transversal and they're not with the same set of parallel lines. So what we got to do is find a way to kind of leapfrog across this diagram. So what I'm thinking I'm going to do is I'm going to leapfrog to here and then to here. So I'm noticing right away that angle 4 is congruent to angle 8. Mark that on the diagram, and I know that that's true because they are corresponding angles. So to angle 4 congruent to angle 8, corresponding. I also know that angle 8 corresponds with angle 13. No, I'm sorry, not corresponds. That's the same side interior. So 3. So now I'm coming down to here. Angle 8 is the same side interior with angle 13. Angle 8 plus angle 13 equals 180. And that's because they're same side interiors. So now check out what I can do. I have angle 4 is congruent to 8, and I have angle 8 in an equation. So I'm going to go ahead and I'm going to substitute in. No, take that back. Let's wait a second. Let's do another step. Now I've got angle 13 in the game, and notice that's vertical with angle 15. Angle 13 is congruent with angle 15 because they're vertical angles. So I've leapfrogged, hopscotched across the board, and so now I've got angle 15 in the mix. And what I want to do now is I'm just going to start substituting like I was going to do a moment ago. I know I can put in 4 for 8. So angle 4 plus angle 8, nope, 13, equals 180. And that's a substitution. I also know that 13 is congruent with 15, so I can put in angle 15 for angle 13. So angle 4 plus angle 15 equals 180. That's another substitution. And check it out. 4 plus 15 is supplementary. So angle 4 and angle 15 are supplementary, and that's your definition of supplementary. There are many ways to do this proof. That was just one way. You could hopscotch across the board going the other way. You could find a way using congruent supplements. Lots and lots of ways to do this proof. All right, Example 5, extending figures for parallel lines and a transversal. In the figure to the right, what are the values of x and y? Justify your equations. So check it out. I have parallel lines right here. I'm just going to go ahead and extend these out and make them look like the pictures that we're used to. I'm going to extend this transversal, and I'm going to start off just looking at this that I highlighted. I've got two parallel lines cut by a transversal, which means that my 2x and my x plus 12, those are same side interiors. So 2x plus x plus 12 equals 180. Same side interiors, that's my reason. Let's go ahead and combine like terms. 3x plus 12 equals 180. I'm just going to solve this now that the geometry is done. 3x equals 168. So therefore, x equals 168 divided by 3. I got 56. Okay, now we're going to figure out the value of y. And I have run out of room. I'm going to come over here to the side and check this out. Now I'm going to extend this transversal right here. So I'm using the same parallel lines, but I've switched transversals. I'm over here. And now I have same side interiors with the 3y and the y plus 20. So 3y plus y plus 20 equals 180, same side interior. And I'm just writing that first equation. That's the geometry. Now all I'm doing is algebra. I've combined like terms to get 4y. I'm going to subtract 20 from both sides. So 4y equals 160. Then divide both sides by 4. Y equals 40. So there's my two answers, 56 and 40. Now it asks us for the measures of all of those angles in the figure. So all I got to do is plug in. This is just algebra. So my 2x angle is going to be 2 times 56. I get 112. That one's 112 degrees. I can plug in my 56, or I can subtract from 180, but I think it's easier just to go ahead and plug in. So 56 minus 12 equals 40. I think I might have a mistake here. All right, so I did find a mistake. This was supposed to be x minus 12, and I had an x plus 12. So when that happens, just go back and fix it. So I have 3x minus 12 equals 180. 3x equals 192. Now divide by 3 and see what we get. I get 64. Okay, now let's go plug in. 2 times 64 is 128 degrees. So my angle at the top is 128 degrees. Now I'm also going to plug in for the other one, x minus 12. So 64 minus 12, I get 52 degrees. Quick check. Make sure your angles add up to 180. If they don't, you probably have a mistake and need to go back and fix it. And that's how I noticed that I had a problem. Now let's go and do the y angles. We have 3 times y. That's 120 degrees. And we have a y plus 20. So 40 plus 20 equals 60 degrees, so that is 60. Again, do your quick check. 20 plus 180, sorry, 20 plus 120 plus 60 equals 180. So that's correct. And I think this is our last example. We're going to find the measures of angles 3 and angles 4. And as we go through, we're going to say how we got it. So here's 3, here's 4. Let's do angle 3 first. Notice we have two parallel lines. We have the transversal. Here's our transversal right there. I see that angle 3 is AIA with 105, so it's an alternate interior angle with 105. So angle 3 equals 105 by AIA. And then angle 4 is the same side interior with 105, so angle 4 equals 180 minus 105 equals 75, same side interior. All right, that's it for today. Thank you for watching.